Welcome. Today, how many freaking days has it been? 106. Exciting news, guys. Look. I got the book. And we're reading it. From page 1. Well, not really page 1, but from the big chapter 1 to the end of the chapter. And we're gonna follow along. And then the reason why I bought it too is because I want this to be like a point of reference to learn languages. So what do I mean by that? It's like, let's say I want to learn, I don't know, freaking Rust one day. I doubt it. Maybe I will. I don't know. Rust seems cool, but I don't really have a use case for Rust. Just for the sake of it, I want to learn it. I'm gonna build it, or I'm gonna learn the syntax, do some problems, like LeetCode style problems, maybe a project. Maybe before that, that's when I would pick up this book and kind of implement the interpreter, and it would be a good place to kind of get familiar with the language. And why am I doing with the Go? Because obviously I want to get good Go practice, and the book is already in Go. Why did I get a physical copy? I don't know. I just wanted. I'm gonna start collecting books. Let me put you guys on my list. I have a list of books that I will all purchase. I will purchase and build. Also, yeah. And if I really like this book, I'm buying the compiler book as well. Designing a data-intensive application is the next one. The thing is, I don't think I can obviously do these on videos because there's not much coding per se. I've heard a lot of good things about these books. Maybe not so, like, I've heard some controversial opinions about Robert. I know some people don't like his style, I guess. Like, one of the advice I remember was like a function should do one thing and one thing only good. Some people disagree with that. I don't know. Who am I to critique that? I don't know shit. So regardless, I'm gonna buy these books. So if you guys have any programming books that you recommend for better, software development, just like upskilling yourself. Like obviously, I don't really care about like some stuff like this. I just put these on because I was curious. These are probably like might get in the future, but these up here are 100% I will be reading, and these are like concept, like software development, like programming concepts per se, not just like how to write Python per se, right? That stuff I can really easily like look up and stuff, which isn't that necessary for a book. So I'll definitely get something like this. So yeah, let me know if you guys have any book suggestions, because I'm gonna start getting into them. But anyways, let's get into it. I'm gonna make a the thing. I actually have done this before with Python, but obviously I stopped doing that because school got in the way and it was not a good language to use, because I actually was conflicting when I was building this stuff. It was conflicting with the actual interpreter of Python, which was really weird. So that was super annoying. So I was like, you know what, fuck that. Let's just figure out when I get time. I'll buy the book and do it in actual Go, and when I pick up Go, I'll be able to understand it more better. So regardless, let's start up a Git repo and document a progress. Oh my god, it's not the file type. Okay. Oh yeah, I have one. Put the programming language as a prefix. Yeah, keep it bare. No need to do any of this. Yep, let me just git add start readme file. What is this? Init. I guess first commit initial. It's called Batman because this commit has no parents. Get it? Yeah. Git commit Batman. Git. Okay, I can't push it. I need to add a remote. Git add. Let's copy this. Boom. And push origin. And so we should be good to go. We're gonna write some stuff on the README. Monkey. We can do a programming language written in Go. Oops. An interpreted programming language written in Go. And then let's just double check. Git add, git commit, initial, readme, chore, readme, setup. Okay, git push and the setup upstream dash set upstream origin to have this automated tracking upstream. Let's actually do that. Git help. Wait, what does this do? Okay. What was the thing? Let me open my dot and git config. Yeah. Wait, what the hell? Why is there a git ignore? That's fine. Okay, I actually don't know how to do this. Let's just do git config set. Yeah, let's set this because I hate doing this all the time. How do I do that? Oops. How do I shoot in the config? There it is. Yeah. Git config dash, I guess, global push dot auto set out remote true. Okay, now I can just push, right? It should automatically do it for me. Very nice. And okay, so yeah, let's start with the first chapter. You probably won't be able to see the book because I have it physically on me. I'm gonna read it. You guys just watch code. So chapter 1 is about lexing. So we have lexing. This is a terrible setup. I gotta figure out how to set this up better. And lexical analysis. In order for us to work with some source code, we need to turn it into a more accessible form, as a plain text is to work with in our editor. It becomes cumbersome pretty fast when trying to interpret it in a program language as another programming language. What we need to do is represent our source code in forms that are easier to work with. We're going to change the representation of our source code 2 times before we evaluate. So take the source code, tokens, and then into an abstract syntax tree. The first transformation from source code to tokens is called lexical analysis, right? It is done by a Lexer. Tokens themselves, also known as a tokenizer or scanner. Some use one word or the other to denote the subtle differences in behavior. Tokens themselves are small, easily categorizable data that are then fed to the parser, which does the second transformation and turns into tokens into an abstract syntax tree. Here's an example. This input gives let x equals 5 plus 5. So what comes out of this Lexer kind of looks like this. Okay. Let identifier equal sign integer plus sign integer semicolon. Okay. All of these have original source code attached in the case of let. Right, so all the tokens have some original source code representation attached. Let in the case of let, in the case of plus sign, and so on. All right. So yeah, well, let's define a token. Make a folder called let's make a token. Token, and let's make our token dot go, and this is a package token, and yeah. So I guess what we can do that, right? Original source code plus representation attached. Let in this case, case of let, plus in the case of plus sign, and so forth. Like then identifier and integer. Length of a white space is significant. Under other languages like Python, the length of the white space is significant. That means the Lexer can just eat up the white space and new lines. It has the output, the white space character as token as so the parser can later on make sense of them. A production ready Lexer might attach the line number and column number and file name to a token. Why, for example, later on, because it would take away from the essential simpleness of tokens in the Lexer, making it harder to understand. The first thing we have to do is define the tokens our Lexer is going to output. We're going to start with creating with just a few token definition and add more when extending the Lexer. Let's break this down. Which types of tokens does this example contain? First of all, there are numbers like 5 and 10. let's define a token data structure, right? So let's define a few things. We need to make, what does it mean to make, what does it mean to make a token, right? So we have a few things here, right? A type, token type, right? Right? Right, which is gonna be, it's just gonna be a string, right? A string. Then type token will build a less complicated data structure here. And what does it mean to have it? So obviously the type, right? Which is the token type, right? Oops. Right. And then what else do we need? The literal. What is that? Right. So what else is there? Like there's the token struct. So what is the literal? The literal is, yeah, so we have a token type. That's basically just a string. And which turns us into distinguish between different types of tokens. Using strings also has the advantage of being easy to debug without a lot of boilerplate and helper functions. Okay, I see. Everything here is going to be represented as a string for simplicity, but performance benefits, you know, because you could use less bytes and stuff. I think, you know, like using the actual data, like an int, actually mapping to a physical int in memory would be a bit more efficient. But writing that would be a pain. Maybe that's a thing to like expand upon. So we have this. This means you can add possible token types as constants. In the same file, we add this. Yeah. So let's make our constants, guys. So I guess is this, like, this is what we're gonna be about. What is it? What are these values, huh? So we have illegal, which is illegal. So I assume like stuff like syntax errors, right? We have in the file representing the end of file, right? So we have stuff here too. So we have identifiers and literals. Oh, I see. So the literals are actually the literals, like the addition, the subtraction, the, you know, comma symbol, the semicolon, right? So like, for example, we have an indent, right? It's not an indent, it's actually identifiers plus illegal. Or not illegal, it's just like literals, right? Okay, I see. Right? We have so which the identifier, which is identify, right? This is a bit confusing. Indent. Okay, I just gotta remember that. We have int as for int Just some basic stuff here, right? We have operators, right? Operators. So we have assignment, right? Assign. We have addition, right? So plus. We could have subtract. They don't put that now, but I think that's kind of the thing here, right? Delimiters. Delimit. Comma. We have, stuff like this, or the semicolon. Right, that's important. That's probably end of the line. We have more delimiters. We have like how do we differentiate, like stuff like this, like a function, right? So we have L paren, we have R paren. So this way, and we basically want these, but brace, right? Which would be useful for like different data structures, assuming they're doing like the Python way, or like a function scope, indicating this is a scope, right? R brace, right? Brace. And keywords. We have function equals function. Let equals let. So far, I know there's gonna be more for sure, like addition, subtraction. This is gonna be a big list, so the two special types, illegal and end of file. We didn't see those in the code example, but we'll need them. Illegal specifies a token or character we do not know about, and EO file stands for end of file, which tells the parser later on that it can stop. So far, good. We are ready to write our Lexer. So yeah, let's do Lexer. Okay, I gotta figure out a better system because I cannot read and type like this. So let's make a Lexer. Lexer. .go. Oh, matter of fact, we're actually running the test first. He's very test-driven development, which is very nice. I need to incorporate that more frequently. Right. So let's build the package. Package Lexer. Let's do import the testing module and the monkey/Lexer. Yeah. Okay, I actually need to set this up correctly. Go mod init. It's gonna be monkey. Okay, github.com, boat Noah, let's call it monkey. Go mod tidy. We're good to go. Oh my god, no, that's bad. Go. We gotta go back. So let's do go mod init and go mod tidy. Okay, I should low-key start a tmux section. Monkey. Is this happy now? Yeah. So I need to specify, it's not like this, it's git github.com/monkey/Lexer. Well, obviously I don't have that file, so it's gonna, I mean, not token, it's monkey token, yeah. Right? github.com/boat Noah/monkey/token. Wait, I'm confused. What is this? Is it like this? Yeah, like that. Boom, 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 boom. Oh my god. Boom. Okay, not yet. We need the token, right? We need the token, yeah. There you go. That's what we want. Token.go. Git add. Git commit. Token file. Created and implemented. Token file created and created. What are these called? Literals, or not literals? Like file created and implemented literal or literals or constants, I guess. Could push those too. Very nice. Let's stick with the Lexer test. So he actually writes a test first, which is really cool. Right. So let's write the function for the testing one. Test next token. Which takes in the testing module, right? The testing code. Right? And we take an input. And, right? Like this, like that, right? And it should be able to tokenize it, meaning it would map to the correct variable, or like the token data structure, right? Let's do all of them. We had a comma, period, semicolon, all of that, right? What else do we have? I forgot we used backticks. Yeah, because I think it's yeah, if we want to use these reserved keywords or reserved ones. And let's write the test, which is basically we take a struct, an array of struct, right? Expected, we implement the thing, implement token dot token type. So this is the expected literal. Okay, so we're making a anonymous struct, or is this like making a struct? Or is this how you make tests? I don't even know. Expected literal. Obviously, same time as that. So it's basically literally the. I go here. It's this. We're expecting this, right? And obviously, we will token dot assign, right? Right. Let's go to the next page. Okay, so yeah, I see that. I see the thing now. I see. I see. So we basically make a struct, like making it look like this, right? Whereas like how many of this? There's an equal. 1, 2, 3, 4. All right, 1, 2, 3, 4, 5, 6, 7, 8. So 9 stuff. So I need a lot more. So I have right now 6. So 7, 8, 9. It's good enough. So assign, right? We have the equal. We have what's up? The assign. We have the plus, right? We have this. We have the right paren. Right paren. Left paren. Boom, boom. We have right brace, right? Right brace, left brace, right? Then we have the comma, right? We have the period. And lastly, we have the semi. I don't know what was it called, I forget. Semi. All right, oops. Test go. So yeah. So test go. Perfect, so this is the test-driven limits. We just wrote something. Let's see if it works, right? You know, like, is this really is this expecting as we are expecting, you know? So yeah. So let's this is, I guess, the Lexer or something. New input. What does this do? New, what does this do? No information available. Sucks. I think that's the thing he makes. Yeah, he definitely makes that. This, I think it's undefined for now. I'm not sure, but we're gonna iterate through the test, right? And call the next token. If the token type does not equal the expected type, then log it wrong. If the token literal doesn't equal the expected literal, then log it wrong. Q. Okay. Gotcha. So we're just going through this for every I and token, range, tests. I guess, what is it called? The token, right, is equal to L.next. This is something we'll implement, the Lexer. We haven't gone to that next token thing yet, so it's not gonna work, obviously. But, so if the token dot, let's start with, what are the things in here? There's token type, so type, right? Type does not equal the expected type. We need to t.log t.fatal test at %d. I don't know what these format stuffs do, but I know that I need to put obviously the expected type. Also, it's actually the expected type, right? Okay, I guess we're defining it and initiating at the same time. I guess an array of it too, which is cool. Very nice. That matches the input, right? We expect, so we logged expected type, right? Well, let me first put literal wrong expected expected q. Okay, I see. Expected percent q got, okay, got, oh my god, so got equals q. I'm not sure what these are. The digit q is, I don't know what q stands for. Token type wrong. Okay. Okay. So it's got q. So actually it's more like which type I failed, test 1 or test 0, and tt.expected type, expected that got token dot type, yeah. Same exact test, but just for the, what was it? The literal, so yeah. Literal. And expected literal. It's more like token type wrong, expected literal wrong. Yep. We will expected the literal, or yeah, expected literal and literal. Can I do this? Oh god, I'm kind of scared now. Literal. Yeah, we're good. Okay. Yeah, and this, I guess, new instantiation is like we're like building a new Lexer, which will like we'll call the thing and then we match. Yeah, this will tokenize this into a matching thing, and if they're not the same, we're gonna log something. We're gonna obviously check for that, of course. Yeah. Yeah, so we're gonna build a Lexer. So let's actually build a Lexer. Very interesting. He starts with a test first, like what to expect first. You know, it's very, very, very nice. So package, Lexer. What are we building here? Type Lexer. Struct. Input the string. Position. Okay. So we have a few things here. Let me read before I type. Right? We have the input string, the position. So the current position in input points to the current character. Read position. Current reading position in after current character. Byte character. Current character. CH is current character under examination. Okay, and the new is just returning a struct with okay. I see the vision now. Most of the Lexers are pretty similar. The ones that might cause some confusions are position and reposition. Yeah, it's a little bit confusing. So we have a position and reposition. Current position and input points to current character. Reposition, current reading position, and input. The ones that might cause some confusion right now are position and reposition. Both will be used to access character in an input by using them as index. So L.input, L.reposition. The reason for 2 pointers pointing into our input string is the fact that we need to be able to peek further than the input and look after the current character to see what comes up next. The reposition always points to the next character in the input. Position points to a character in the input that corresponds to the character byte. Okay. So we're gonna make a function that a method, I guess. I don't want to sound object oriented. I know Go is not object oriented. It's gonna be something that implements the Lexer struct, which will read the character by moving it forward, right? Okay, so if the reposition is greater than or equal to length of L.input, then we reset the character to 0. Oh, wait, what the fuck is this? That's weird. So we say L.position is L.reposition and increment read position. Okay. I'm kind of confused why they put the character as a byte and actually use... which is the ASCII code for... which is the ASCII code for null. What's the default value for position? I'm not curious. I think it's 0, 0. Okay. We're also going to point out that the Lexer only supports ASCII characters instead of the full Unicode range. Why? Because this lets us keep things simple and concentrate on the essential parts of our interpreter. In order to fully support Unicode, and we will need to change the L.change from a byte to a rune and change the way we read the next character, since there could be multiple bytes wide now. Using L.input, L.reposition wouldn't work anymore, and we would also need to change a few other things and functions we'll see in later on. So left as an exercise to fully support Unicode and emojis in Monkey. Okay. That's something we could do for once we finish it, is to support Unicode character. Let's write that down, as I feel like there might be some things to I guess features to implement. Full Unicode support for the Lexer. Yeah, whatever. Back to Lexer.go. So position is int. I spelled that shit wrong for sure. Position. My god, I don't know how to freaking spell position. Yeah, position. And then what else do we have? We have the read position, which is one above it, and the current character under examination. So these two are the same thing, but this one is one above this one. so we can peek later. And we need to implement l.lexer read character, right? What do they call it? Read what? Actually, let's actually make a constructor. Again, me using these damn terminologies. Input string, and it would be L, which is the Lexer of input, and then return, we'll just return an address. Oh, I need to specify that Lexer. Is that good? Okay. Does this make a difference? So we're returning a Lexer, and then let's implement some features, right? So let's read the character, right? So reading is pretty important. So let's be defensive. So we're gonna actually do error handling first, right? So if l.read position is greater than or equal to length of input, right? We just want to return, or not necessarily return, we're not really returning, we're just going to set l.sheet2. Again, these are ASCII values. Not, yes, this is wrong. This is a byte. Represents the current letter under examination represents examination, under examination in ASCII. Obviously I gotta say l dot input, right? Else that means we're going to l.sheet is l dot input, l dot I guess position, right? Because this is position is going to represent the current thing we're currently implementing, right? L dot okay, and then L dot position equals. Can we just increment? Oh, position doesn't really increment. It takes the value of read position, right? Position, right? And we just increment this, right? Right? Boom. That's what we like. Right? Oh, actually, I'm confused. Current position in input points to current character. Okay, they actually do read position. Okay, what am I not understanding here, right? Why is this the case? Gosh, explain this to me. So what does read position really mean? Read position means, let's do reading. Okay. The ones that might cause some confusions are position and reposition. Both will be used to access characters in input by using them as an index. The reason for these two pointers pointing into our input string is the fact that we will be able to peek further into the input and look after the current character to see what comes up next. Reposition always points to the next character in the input. Position points to the character. Okay, I see. Points to the character in the input that corresponds to the character byte. Points to the next character in the input. Oh, okay. So if we start, basically we're starting like, okay, let's say we had this, right? Right? We have like this, right? Right? I think what it's saying is we have like P is here and R is here. Next is take this, right? Read, this is your new position now, and then move on, right? And then use that like this, and then like this. Now it's like this. Now it's like this. Now take this, so basically read this. Now this is your new one. Okay, I see. Makes more sense now. Very nice. What to next? All right, so read L.reach. So when we make our constructor here, again, I know it's bad terminology to say, when we kind of make a new Lexer, we actually want to call it because we want to initialize like this, right? We want to start like this, right? Right, we want to start like P is here, R is here when I create it, right? Okay. Very nice. Also, how does he like to call his like test each file out? All right, we're gonna implement a new we're gonna implement Okay, I see the vision now. We're gonna implement 2 more functions that will like spin this up. This is really fun. I like this one. Right? We need to do something that builds the kind of, we can call, remember this function, guys? Lexer test. We need to call this, like, this is literally next token. We don't want to return strings, right? As if like the read character does, right? Right? Which actually just reads the character. We want the actual token. So we need to map the literal thing to a thing. Like we need to map, every time we read it, we want to create a token, right? So when we read it, so what is the type, right? And what is the, and then we make a token, and then we kind of read that token and return that token. Okay. Well, so we need to basically map the physical input, the elements in the physical in the string to a token class, right? Let's remember that. We actually need to import the import github.com/boat/noah/monkey/token. I'm sorry. I know this is such a terrible. I mean, it's convention to use your remote repo thing, right? Or I mean, you tell you use whatever, but I heard it's convention, so whatever. I stick with the sheep mentality. So we're gonna build 2 functions, right? I'm gonna close this book now. I might do pre-reading and then see if I can implement it, right? So it really I can grasp understanding. Let's see, next token and new token. Okay. So let's do this. Let's func. It's gonna be a part of the Lexer class, obviously, called next token, right? Which obviously returns me a token. Does that make sense? Token. I don't know actually. What does that even make sense? What type am I returning? Oh, doesn't make sense. We're token, right? That makes more sense because we're this. It's the file. Yeah, token. Yeah. So we're gonna say var toke is token, right? Well, I need to specify where it's from, right? And do a switch statement. Switch, which is the current byte we're reading, and what do we say? Case. Let's start with I don't know. Lexer.go. Case C. Well, not C, what am I saying? Equal sign, right? That means a sign, right? So that means token, new toke, yep, and then we're gonna pass in token dot assign the variables to and the literal. And I need to make that. Well, let me write all these out first. There is about, how many literals I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, Or actually, how many does this have? 1, 2, 3, 4, 5, 6, 7, 8, 9. About 9. So let's do that. So yeah, give me back here. Oh load. Let's do 8p. So this one is a semicolon. So do token dot oh my god, fucking Vim. Semicolon. Right? Next, we have left. Right paren. Right? No, it's left, dumbass. And then we'll do right paren. We have, what else? This comma. Yeah, comma. Plus. Plus, yeah. What else is there? The right brace. Let me read the input. That's fine. Right brace. So we'll say, or L brace. R brace. And then case 0, meaning it's null. We just say I don't even know what we, I guess illegal. Oh lord. And then what does it mean to, and then we obviously return. Okay, so return the token, but we also want to move our pointer read char. And we'll actually make a kind of constructor for the token. Yeah. New token, which will take in the or I guess, what is that called? I don't even know what to call it. The token type, yeah, token type of token type, and literal, which just byte. What do they call this one? Yeah, character. We're putting the character in, so we'll say that. By no. Right? Token type, token dot type, the physical token, right? Well, no, it's not really token type. What is it? What type am I really putting? Token type. Oh yeah, for sure. This is, yeah, this. We're talking about this. This is a token type, and a token takes that. Yeah, we take it. We need those two and a literal, right? And then we can return. Obviously, this returns me a token, and let's pointer, right? Token dot token, and yeah, just give me the address of token, which takes the token type, and literal. How did it do? Oh, it's type. token type, literal. Shit. Does it, what do they do? Do they convert it to a string? Yeah, they do. Boom. I probably need to make this appear because it's going to be used. Why is it crying? What's wrong with this? Oh, we don't. Okay, not an address. As a new copy. Yeah, that's what I was calling. We want a new copy. Yeah, not a copy. Like yeah, make a new one, not a pointer. What am I saying? Yeah, this is it. So now we can test it. Running tests, we can see they pass. All right. Wow. Do I have to build this? Go test. I guess go. Does he build? Okay. Go test dash v. Oh shit. cd Lexer. Lexer. Who is missing a semicolon? Missing semicolon. Lexer test. What semicolon? Oh my god, I think it's this. Period. Is there no period? No. Did I miss a period? Or is there just no periods in the... I think there isn't. I think I messed up. Yeah, there's no period. What am I doing? There's a plus equals. Yeah, that should be good. Also, this is a test. And next token. I think I mistyped. Next. Yeah. It wants to be imported. Test. Oh, okay. What's going on here? T.fatal. Brother. Oh, fatal F. Go test. Fail. Hold on. I might have gone the wrong thing here, right? We have equals plus. Yeah, there's no this. Fail. Expected this but got that. Okay, hold on. We have a plus equals open. Okay, but I got these wrong. It's L paren or right paren. Okay, what am I doing now? Expected that. Okay, got that. Yeah. This is left paren left brace. Dude, VIW, right brace. Wait, what the fuck is a right parentheses? Yes, it's this way. Yeah, what the fuck am I doing? Wait, does that mean my test Lexer? Yes, right, left, yeah. Which side is it open? It's open on the left side, yeah. Well, why am I tweaking out today? Holy crap. Now this must pass. Oh my god, what is this time? Equals, got that, okay. I think I got the ordering up. Equals plus left paren, right paren, left brace, right brace, semicolon, equals. Why the fuck is there equals? It should be this. Passed. Well, wait, am I doing this right? What's with this? Equals plus the oh, I see. And then token dot in the file. EOF. Does that work? Fails. Yeah. That. Got that. Yeah. Plus equals plus, yeah. Gotcha. That's their issue. Okay, so this fails because the Lexer doesn't consider the case here. Like L dot or the token literal, we just literal. We expect it to be this, and token dot type, just make it equal to token dot EOF, and we don't even need to do that. Right, so now it will pass. No, it won't. Go test Lexer.go. Or do I put a space here? Fails. Why? Equals plus open left right, comma, semicolon, there. Oh my goodness, it's not detecting that. It's not the character, this is the ASCII value, yeah. Very nice. List. I think we can do this next time. How long has it been? About an hour and 15. great work. Hope you guys enjoy this new series, right? Feet created Lexer and its functions. Yeah, let me know if you guys like these series. If you have more books to recommend, I would love to go through them. So regardless, made some decent progress. Tomorrow we're gonna expand it so that we're gonna test more if I'm writing this right, you know. We're gonna write it so it looks more like an actual language. Like, let's do this. Let x equals. Let's look at this. Okay, it doesn't like when I do that, so. Let 5, okay, wait, 5 equal 5. Right. Let 10 equals 10. Let add equal fn xy. X plus let result equal add 5, 10, and then we can get rid of this. Obviously, I need to make it like match it here. So, anyways, we'll do that for tomorrow's video. Thanks for watching as always. I'll see you for tomorrow's video. Peace.